Okay, so let's continue. The vestibule, like I said, the utricle and saccule are for linear acceleration. Just going to keep repeating this and harping on it. Semicircular canals are for angular acceleration. And then what else do we have? We have the cochlea, which is associated with hearing, right? So I'm just going to keep repeating highlights and important stuff. Round window versus oval window, which is the one that actually is affected directly by the ossicles, which is essentially the stapes. Is it the oval window or the round window? Well, if you remember spat, miss, ocha, so spat, S-P-A-T, sound, pinna, auditory meatus, tympanic membrane, miss, malleus, incus stapes, and ocha, oval window, cochlea, hair cells, and auditory nerve, then you know that oval window is the one that connects to the three ossicles, miss. But round window is essentially the best way to say it is release valve for pressure. And equilibrium, hair cells in general receive information and transmit it through to the cranial nerve 8. Semicircular canals, what is that for? That's for angular acceleration, right? Ampulla, cupula, just remember that's a part of the semicircular canals. Stereocilia and kinocilium. Yes, I want you to remember this one. He is king. So there's a way to remember this. It's surround sound. So you find stereocilia in general as surround sound for you and surround sound for the sperm. Obviously, it's not going to be found in women, but in terms of the reproductive tract, but it's going to be found in men. So stereocilia, surround sound for you, surround sound for sperm, and that means that you're going to find stereocilia inside of the ear and also inside of the reproductive tract for males. And then kinocilium is king. He's the largest cilium of them all, and he tells the others what to do. So here we go again. Semicircular canals for angular acceleration, utricle and saccule for linear acceleration, and the cochlea for hearing. Goes through the vestibulocochlear nerve. Vestibular branch is for equilibrium. Cochlear branch is for hearing. So again, we have the cupula, ampulla. It's just a part of your semicircular canal, right? Hair cells for transmission of equilibrium, movement. And if I'm talking about angular acceleration, it's going to be semicircular canals. If I'm talking about linear acceleration, it's utricle and saccule. The kinocilium, he is king. You're going to find him here, right? Semicircular canals. And he's associated with the stereocilia. So endolymph, utricle, saccule, linear acceleration, right? Statoconia, what is the whole point of having statoconia? Well, otoliths are ear stones. Otoliths are ear stones, and what you can think of it is this. Let's say that this represents a feather. And if I move the feather sideways, right, like this, the feather is not going to really move much. But if I add some heavy substance like tiny little stones to the end of the feather, as I turn it sideways, gravity will affect it greatly by pulling it downward. And that's one way to assist using gravity, but assist with your body responding to the changes in gravity. So if it's utricle and saccule, it's linear acceleration. If it's semicircular canal, it's angular acceleration. So here we go, vestibular, vestibular, all equilibrium, and equilibrium again. Same thing, vestibular branch for semicircular canals and utricle and saccule for equilibrium. And if it was cochlea, then I know that it's going to be for hearing. And the combination of the two is just cranial nerve 8, vestibulocochlear, also known as auditory. Is it sensory, motor, or both? It is sensory, right? Eye, head, neck. So the ear helps to coordinate all of this. If I have anything that damages, right, damages this nerve passing into the brain, it could be something as simple as having earwax in the ear, right? Not being able to hear. Maybe you have damage to the nerves, and maybe you're sick and you have an inner ear infection or middle ear infection. If you have a middle ear infection, it can throw your balance off. You might have vertigo. And so there's a lot of connection between the eye and the ear. Nystagmus is the rapid movement of the eye that's not normal. It's usually or could be a sign of damage to the brainstem or the inner ear. So let's do some questions. Balance, equilibrium, what cranial nerve? Cranial nerve 8. What part of the cranial nerve 8? Vestibule. And what are the structures associated with the membranous labyrinth? I'm not going to ask too much on that. You just have to know it's like utricle, saccule, cochlea. The vestibule is the utricle and the saccule, right? That's the biggest part of it, and that's for linear acceleration. Semicircular canals are for angular acceleration. I will not ask these, so you don't have to know the 3 different parts of it. If you're taking the 300 level next, then she will probably break down what each division will detect in terms of rolling forward, rolling sideways, spinning on a chair. So they detect different aspects of angular acceleration. What is our semicircular ducts? Just remember that they're associated with your angular acceleration. You guys can go through this. And hearing, cochlear, this one is fun. It's probably the more challenging of the two between the vestibule and the cochlea. I look at this as a snail shell that's been cut in half, right? So if you look at this is the snail shell, and all I did was I cut a clean line straight through, and I'm looking at 1, 2, and 3 chambers. So again, I'm looking at 1, 2, and 3 chambers, and this is just swooping around and around. You could simplify this and look at it as though you're unraveling a toothpaste tube like Aquafresh. And Aquafresh has 3 different colors in it, right? It's like red, white, and blue. And so the most important part is the blue. I like the blue. And it has what we call the organ of corti. This structure here is the organ of corti, and it is associated with your hearing and transmission of sound. It is in what we call the scala media. It's smack dab in the middle. This one here on the top versus this one on the bottom, they're just chambers that help with storage of fluid that helps to send the sound through these pathways. But this guy here is called vestibuli, right? So scala vestibuli. And this one on the bottom is called scala tympani. So how I remember the 3 chambers is vomit, VMT. And VMT, we saw this earlier, this is endolymph, this is perilymph. So this has high concentration of potassium. This has high concentration of sodium and chloride. So your sound transmission is triggered by the movement or changes in potassium. So again, here we go, same thing, vomit, right? VMT, vomit, VMT. Organ of corti, or the spiral organ, is found in scala media, and that is one of the most important ones that I want you to remember. So again, hearing, auditory ossicles, what were the 3? Malleus and Stapes, and what do? They transmit sound. Basilar membrane. Let's get to an image that we can actually play around with. So vomit, VMT, vestibuli, media, and tympani. The most important structure for sound transmission is found within here. It's called the organ of corti, right? And this guy is found within the scala media. Let's take a further look at this. If you've ever gone swimming off Hawaii Kai, there's caves, right? So the caves have these rocks and the rocks on top, and then they have waves that are pushing underneath the rocks that create this little cavernous structure underneath. And so I imagine sound waves, which are transmitted along this thing called the basilar membrane. As sound waves are being transmitted and as waves are being propagated, kind of pushes these cells up and into this hard structure here. Every time you push into the structure, it triggers the movement of potassium, which then sends sound. It's almost like a symbol of sound being sent through all the way through the nerve fibers. So one more time, tectorial membrane. This whole structure is called the organ of corti, but the tectorial membrane is the hard surface that these cells push against when a sound wave is sent through the basilar membrane. No, that's hard, but just remember that, one more time, scala media has organ of corti for sound. Once the wave passes through the basilar membrane, it triggers the movement of these little structures which send a signal to the nerve cell indicating that sound is occurring at that point. And what does this mean? Well, what is sound, right? Sound has parts to it, almost like a wave. A huge wave that is that big is going to be really intense compared to a tiny wave that's like this, right? So there's also intensity, right? Intensity is like the height of the wave, but then there's also frequency. How many waves are coming at you at one time? So the more waves you have, the higher the frequency you have, the higher the hertz, the higher the cycles, the higher the pitch. So a high pitch sound is going to have high frequency, but a low pitch sound is going to have low frequency. Okay, hopefully that helped you a little bit. Amplitude, on the other hand, is the intensity of the sound wave. So if I'm standing at Waikiki and the surf is like 1 inch high, is that a big wave that you're dealing with? No. But let's say I'm standing at Waikiki and there's a tsunami coming at me. It's a huge wall and a huge wave that's coming at me. So is the intensity greater? Yes, it is. Therefore, the volume, the loudness, and the amplitude of the sound wave is much greater. And we measure that in what we call decibels. So that's just showing you sound waves. The distance between the two, right, is your frequency. The height of the wave is your intensity or amplitude. And then this is the important structure I want you guys to look at. Imagine this as a toothpaste tube, Aquafresh, right? So Aquafresh, over here is the cap, and some of us, we like to squeeze the tube all the way until all the contents are gone. You kind of like roll up your toothpaste tube until you really squeeze out every bit and piece of that toothpaste to make sure that you use it all up. And so this part that has the cap on the toothpaste tube, is it more stiff than the other end, or is it more flexible? Well, this guy, we call him the base, and we call this the apex. So the base of in the cochlea is actually stiffer, kind of like the cap of a toothpaste tube. And so when you hit something that is metallic or really hard in nature, the pitch itself is really high. So how I remember where the pitches are along this basilar membrane is that the stiffer it is, the higher the pitch. The more flexible it is, the lower the pitch. So if I have a rubber band and I make the rubber band really tight and then I strum it, it's going to have a higher pitch than if I let it loose and I let it lax a little bit and then I strum it again. So toothpaste tube, you can say this end with the cap, it's going to have more stiffness and higher frequency. So one thing about this, I'm going to make the sound. So this is me hitting my knuckles over and over and over again. Okay, so that's like hitting knuckles. Imagine hitting your knuckles for 50 years, 60 years, 70 years. What happens over time? Well, you start to damage it. So this structure, because it's stiff and it's adjacent to the bone, right? Malleus incus stapes, it's pushing inward. The more you hit it, right? The more you damage this area, the more you lose high-pitched sound. So as you get older, you lose the ability to hear higher pitched sounds. So when somebody's talking to you like this, you can't really hear them. So what do they have to do? They have to speak really low when you're talking to them, right? So as you get older, I actually had a student that I knew that had the highest pitch voice ever. And she had to go into a geriatric ward and speak with some of the residents there, and they couldn't understand a word she said. So she had to go from, "Hi, my name is Joy," to, "Hi, my name is Joy." And it was just the funniest thing. Sorry. So again, transmission of sound. And then in terms of human hearing, our ability is within this range here. So within 5,000 to like 1,000. But a dog whistle pushes up in the higher pitch range where we cannot hear. So same thing, just going through what we already know. So sound, so spatmus ocha, sound, pinna, auditory meatus, tympanic membrane, malleus incus stapes, oval window, cochlea, transmission through hair cells, which triggers the auditory nerve, also known as vestibulocochlear. The vestibule was associated with equilibrium. Cochlea is associated with hearing, and that is cranial nerve number 8. Is it sensory, motor, or both? It is sensory. So same thing. Cochlear branch we already discussed. Auditory pathways we went through. Very basics. I can ask you further, but some of the things that we might have covered previously was 5, 6, 7, 8. Who do we appreciate? Pawns, pawns. Yay, pons. So you know that the pons is associated with cranial nerve 8 as well. And transmission of sound up into the brain, you're going to have to send it to the thalamus, right? And he's the relay station to send it towards the temporal lobe, which is associated with sound. Hearing range, like we said, decibels was a measure of sound intensity and loudness. Effects on aging, we talked about that. And here we go, the last of it, sound. What is the pathway for sound entry into the auditory system? Spat, Miss Ocha, you got that down. Are the parts of the external ear? Spat. What about middle? Miss. What about inner? Ocha. And then muscles to reduce sound transmission. One attaches to the tympanic membrane, the other attaches to the stapedius. You guys can review that. Cochlea was for sound transmission. Scala vestibuli, remember vomit, VMT, which one is the most important that contains the organ of Corti? We said that was, I'm not going to say what it is, you guys can go and review it. And then vestibular membrane, not as important as the basilar membrane in which the sound waves are transmitted. And then along the basilar membrane, we said that one end was like a toothpaste tube, right? So one end was like the cap and the other was like the tail. The tail is flexible, low pitch sound here. The cap is it has stiffer material, so high pitched sound on this end towards the base versus towards the apex. Like we said, what's found there, what is the organ of Corti, and we're done.